Bismillahirrahmanirrahim. This is another video on T and pi equivalent network from chapter number 13, linear transformer. And here primarily we'll be discussing example 13.6 and solve practice problem 13.6. Let me just recall what we have discussed in the previous video, that if the dots on the transformer are at the top or on the same side, then we'll use this formula. L1 minus M, L2 minus M, and M for the T network. But if the dots are on the opposite side, then we'll replace M here with minus M. So it will become L1 plus M, L2 plus M, and here it will be minus M. Now this is LA, this is LB, and this is LC. Now keep in mind that the current direction does not matter. So we just follow these two. Now, example 13.6, solve for I1, I2, and v-naught using T equivalent circuits. We have to replace this transformer with the T equivalent circuit. And since the dots are on the opposite side, therefore we'll use this circuit. So we insert in place of a transformer, we inserted the T circuit. And just to calculate the value, we want to be sure this is L1, this is L2, and this is M. So now LA, this is LA, LA is L1 plus M, L1 is 8 and M is 1, so 8 plus 1, 9 Henry. Similarly, LB is 5 plus 1, 6 Henry, 5 plus 1, and LC is minus M is 1 Henry. We need to convert them into the frequency domain, so we'll add J with all of them. So J9, this is J6, and this is minus J1. And now we just mark the polarities depending on the current direction, so we can easily write the KVL equation. So left loop, we start KVL equation from this corner, and we go like this. I'm sure you know how to write the KVL equation. Minus 6 from here, then I1 4 plus 9 I1. Here we have two currents, I1 and I2, and since both these two currents are on the same direction, coming from top to bottom, therefore they'll be additive. They'll be added. So minus J1 and I1 plus I2. Simplifying and collecting the like terms for I1 and I2, we get this answer. Now the second loop or the right loop, again will follow the same technique of writing KVL. I start from left corner, you may follow any other technique. And so from here, minus and then minus J1, so minus J1, current I2 plus I1, since we are in loop 2, so we'll write I2 first and then I1, and then minus J6 I2 because of the sign minus first, and this is minus 10 I2, and collecting the like terms, we get the second equation. Now, the book has followed the technique of substitution. You can do that. And actually, I'll show you in the next problem. But here, just what you could do is find the value of I1 from here. Plug in that value of I1 into equation number 1 and calculate I2. After I2 is calculated, you come back here and put the value of I2, so you can get I1. So this is how it has been done in the book. But I feel more comfortable with the matrix method, so I'll write matrix method. So these are the magnitudes from here. And as I have explained in one of my video, how to easily solve this type of question with the calculator in complex mode. So for that, first of all, we assign these some variables We'll call 4 plus J8 as A, this one B, C, D, and this one E. I'll tell you how to assign in your calculator. Okay, so once it is assigned, we take the determinant. So this is determinant, and determinant can be written as AD minus BC. So we have written that. Delta 1, again, in the delta case, delta 1, we replace the first column with the output. So we replace that, and now ED and minus 0, so ED. Similarly, delta 2, we replace the second column with the output, so second column is replaced. And now this is 0 minus CE. And we know the formula for current is delta 1 over delta. So ED, this ED divided by delta. And I2 is delta 2 over delta. So delta 2 is minus CE divided by AD minus BC. Okay, and once we calculate this, I'll show you how to do that. We'll get this as I1 answer, and this is I2. So let's now use the calculator. First of all, you have to bring your calculator in the complex mode. Press 2. The calculator is in complex mode. Now we'll assign the values first of all. And to do that, 4 plus J8. So we'll write 4 plus 8. For J, we write I. So 8I, shift store. And we'll assign this as value A. So this is A, B, C. So we press the negative sign. So A is assigned to this, clear. Then B is minus J1. So minus 1I, shift store B. So it is assigned. C is J1. That means 1I, shift store C. C is assigned. And D is minus 10 minus 5. So minus 10 minus 5I, shift store, and this is D. So D is here. So this is store. And finally, J6 is A. So 6I, shift store, and E. This is E. So E is stored. Okay, now we have all the values stored. Now we'll straight away come to this formula to calculate I1. Now this is in terms of a fraction, so we'll use this button, ED. Now to enter ABCD, we have to press alpha every time. So alpha E and alpha D. The numerator is done. We move to denominator, down AD minus BC. So alpha A, alpha D, minus alpha B, alpha C. Move ahead, equal sign. So this is the answer. Our answer is in a polar form. To get that, shift complex 2. The option R theta will select, that is 3, 3 equal sign 0.6067, 0.67, and angle is 20.137 or 20.14. So I1 is calculated. Now we can calculate I2 same way. So let's go here, move left. We are on this. Keep moving left. Denominator, no change. Numerator, we need to change. So we just delete. Minus CE, minus alpha C, alpha E. So this entry is done. Now let's go to the end. Here, equal sign. We have got a value in rectangular form, shift complex 3 equal sign 0.599, that means 0.06, and angle is 90.57. So this is how I1 and I2 you can calculate with the help of your calculator in complex form. Okay, now that we have calculated I1, I2, we need to calculate V0. Now look at this circuit. The current direction, according to the current direction, it should be positive at the bottom, negative at the top. But V0 has been defined as positive at the top, negative at the bottom. So we have to put a negative sign with the answer. So we'll write V0 is equal to negative 10 into I2. Then this is 10 I2. We have to put a negative sign. And I2, this value, so we plug in. And so we get negative 0.6, 90.57. Now negative 6, actually, if we consider negative 1, negative 1 is, if you go into the number line, it is 180 degree. From 0, 180 degree, you can go to the negative sign, or 0 minus 180 degree, you can go to the negative sign. Since the answer is in negative, therefore instead of positive, we'll write negative here. The negative sign is replaced by negative 180 degree. And now solving V0 is 0.06 minus 89.43. In the book, the answer is given as 90. Okay. Now we come to practice problem 30.6. Now here the dots are on the same side. So we'll use this formula now. Calculate LA, LB, LC. Now L1 is 5 and this is 3. So we have calculated all the three values. Write on the T equation the values 2 Henry, 3 Henry, 3 Henry. Put it in the circuit. But to solve, we need to convert this into frequency domain. So we have to just add J with them. So let's see. We have added J, J2, J3, and here also J3. And also we have marked polarity depending on the direction of the current. So positive, negative, positive, negative, positive, negative. Now we are ready to write the equation. So this left loop, negative 12, and I hope you know how to write J4 plus J2, I1, and now here the current, there are two currents here also, but the current directions are different. I1 coming from top to bottom, I2 going from bottom to top. So we'll write it as I1 minus I2. So J3, I1 minus I2. Simplifying, correcting the like terms, this is our first equation. Similarly, we write the second loop equation, J3, and now we will write I2 minus I1 since we are in the second loop, and this is 12J3. Okay, solving. So this is our second equation. Now I'll show you how to work with the substitution method. So let's do that. From here, we collect I value of I1 like this. Using our calculator, you get 2 minus J4 I2. Now we put this value here. So putting this value and solving I2, this ratio again, you need to use your calculator. So this is the answer for I2. Now that we have got I2, we'll put that value here to get I1. So I1, putting in the value of I2, this is I1. So these are the two answers given in the book, same answers. Okay, now those, I hope you have learned this, but those who are interested for them, I'm just reproducing the matrix method also. So just write the equation, two equations, and from here we write the matrix equation. and we assign the value, calculate delta, delta 1, delta 2, and I1, delta 1 over delta, I2. And as we have shown in the previous example, use your calculator in the complex mode and calculate. You will, first of all, you assign these values and then calculate. So the current is 13.01, this angle, and I2 is this. So it's the same that we got by the substitution method. So this was the answer. So I hope you have been able to follow this. Let me know which technique you feel more comfortable, the substitution method or the matrix method. Thank you.